Welcome back to the chemistry videos, and in today's video we will learn about knocking. We have already talked about octane and cetane number, which determines the quality of the fuel. But there we have kept talking about the knocking and anti-knocking properties of the fuel. So let us first understand what is meant by knocking. Knocking is actually a loud sound which is produced as a result of combustion of the fuel. But how it takes place and what is the exact definition of knocking of petrol and diesel, let us learn in detail. So, as I said, that the large metallic sound or sound of a rattle, when the kids are there and they are crying, we play a rattle for them, which makes sounds. So same type of rattling sound, when it is heard, it is called knocking. So what is the knocking in the petrol engine? It is defined as the sudden ignition of the last portion of the air fuel mixture due to the increase in the compression ratio, leading to the production of a large metallic sound, and this is called knocking in the petrol engine. So if the knocking is there in the diesel engine, it is explained as the metallic sound produced due to the delayed ignition of the fuel in the engine by its accumulation in the engine, and then on attaining the ignition temperature, it burns with an explosive ignition, resulting into a large metallic sound. And this is called knocking in the diesel engine. So, I think I should explain it in a lucid manner, because these are the definitions. Then exactly what is knocking in the diesel engine? Very simple. It is the metallic sound which is produced due to the delayed ignition of the first fraction of the oil-air mixture. Whereas the knocking in the petrol engine is the sudden ignition of the last portion of the air-fuel mixture. So this is the basic difference between the knocking in the petrol and diesel engine. When the ignition is sudden in the last portion of air-fuel mixture in the petrol engine, it results to knocking. But if there is a delay in the ignition of the fuel in the engine, due to the accumulation of the oil in the engine, it results into an explosive ignition. Then it results into knocking, and this is the knocking in the diesel engine. So what happens when there is a knocking in the engine? The knocking leads to mechanical damage to the cylinder parts of it. Why? Because as a result of knocking, there is overheating of the air-fuel mixture, which results into abrasion of the different parts of the cylinder. It also decreases the efficiency of the engine, because when the knocking takes place, a large part of the energy is lost in the form of sound energy, which is a result of collision of the molecules of fuel with the walls of the cylinder, that produces the rattling or the metallic sound. It also results in an increased consumption of the fuel. It produces a very harsh sound, unpleasant to the ears. It also decreases the power output. Therefore, knocking is not desirable. How we can prevent the knocking? So we should take certain measures to prevent the knocking. First and most important is using a high rating fuel. Already we know how the fuels are rated on the basis of octane number in case of petrol and cetane number in case of diesel. So we should use a fuel with a high octane or cetane number. We should also learn about the critical compression ratio, because the compression ratio is very important while determining the knocking. So the highest useful compression ratio should be taken into consideration, and it should not exceed beyond the higher useful compression ratio. Otherwise, it results into big knocking. We can also add anti-knocking agents such as tetraethyl lead, tetramethyl lead, diethyl bromide, diethyl telluride, etc. as dopes to the petrol to reduce knocking in the petrol engine. Similarly, to reduce the knocking in the diesel engine, we can add to the diesel the dopes such as ethyl nitrite, ethyl nitrate, isoamyl nitrites, and acetone peroxide. So these measures can lead to prevention of knocking. What are the differences? Now that we have learned the knocking in the petrol and diesel engine, let us see the differences between the two. So in the petrol, it is the spontaneous combustion of the last portion of the air fuel mixture that results into knocking. But in diesel, it is the delayed ignition of the initial part of the hot air and oil vapors that leads to knocking. In the petrol engine, the air and fuel are drawn together in the cylinder and then it is compressed. Whereas in the diesel engine, the fuel as oil spray is allowed at the end of the compression ratio, which already has air in the cylinder. In the petrol engine, the straight chains such as N-heptane is given a value as 0. Whereas in the diesel engine, it is the branched chain compounds in the diesel which is given a value as 0. In the petrol, the branched structures such as 2,2,4 trimethyl pentane, also called isooctane, is considered as 100. And the petrol having a large quantity of isooctane is considered as a good fuel. But in the diesel, the straight chain structures are preferable, such as N-hexadecane, and it is given a value as 100. So the diesel containing large quantities of N-hexadecane is considered as a good diesel fuel. To minimize the knocking, to the petrol we add tetraethyl lead, tetramethyl lead, diethyl bromide, diethyl telluride, etc. as dopes, which minimize knocking and are called anti-knocking agents. But in the diesel, ethyl nitrite, ethyl nitrate, isoamyl nitrite, acetone peroxide, etc. are used as anti-knocking agents. So now we have learned knocking in detail. We should not forget that the coal and the crude oils are fossil fuels, and on combustion they leads to environmental pollution, though we use them for our energy satisfaction. We'll continue with the knocking mechanism in the diesel engine and in the petrol engine in my next videos. Keep watching, like and share, and also comment in the comment box. Thank you very much.